Okay, oh yeah, good, mic's on. Just threw this on the last second. So today I'm going to talk about irrigated specialty crop research. Here in southern Alberta, we're located in a bit of a unique agricultural production region. We're influenced by climatic factors, geography, we have access to irrigation water, soil that's suitable for irrigation, and we have a population of farmers that are relatively ambitious and innovative. And because of that, we have a rather diverse irrigated specialty crop sector that is, it's diverse and it's quite profitable as well. So today I just want to dig into that a little bit. So I'll start by talking about the region itself, why it's important, the characteristics of our region, and how that dictates how we grow crops, the types of crops that we grow, and some of the strategies that we use that may not be applicable in other areas across the prairies or even the country. I'll talk about some of the trials that Farming Smart has done on some of these irrigated and specialty crops and what we've contributed to the sector. And I'll wrap up by talking a little bit about what's next. This map shows the growing degree days for the prairie provinces. You can see, obviously, the southern portion of the province, we kind of get the most heat. This is base 15 growing degree days. So there's between Lethbridge and northern Ontario, southern Manitoba, lots of heat throughout the growing season. Things start to differentiate a little bit once we start looking at what it looks like when we're looking at precipitation. So you can see that when you get into central Saskatchewan, central Alberta, Manitoba, there is considerably more moisture than we get here on the prairies. And in fact, looking at Lethbridge, sort of that Palliser Triangle region, by this metric, we're looking at 4 to 7 inches of rainfall in some of those areas. So this is a big influence in how we grow crops, the crops we can grow, and really highlights the need for irrigation waters to supplement our production systems. This is a map of the soil zones in Alberta, so this is sort of that geographic factor. And part of this is influenced by that climate, right? The many years of hot and dry periods of weather, we're not developing as much organic matter over the years. And we also have unique parent material. It's lacustrine soil, lots of sort of silty loam type soils. So that all kind of influences and also makes the soil quite suitable for irrigation, which of course we've got relatively plentiful source just to the west of us in the Rockies. And we can use gravity to convey that water to us. So we're ideally situated to be using irrigation for production. Average growing season precipitation is about 6 to 7 inches. In recent years, it's been a lot more grim than that, less than 4 inches, less than 2 inches, maybe even less than an inch in some areas in this past year. So when we're looking at crops that require 14 inches for optimal production, this is, we're very moisture limited, and it's a pretty important piece to allowing us to be as productive as we are in this region. When we move into some of the specialty crops, things like potatoes, corn, and sugar beets, we're kind of in that 22 to 24 inches of moisture needed to grow these crops. So that's a lot of supplemental irrigation that we need to be considering. And that's why we do have so much irrigation use here in southern Alberta. So in fact, of all the irrigation in Canada, Alberta constitutes about 70% of irrigation in Canada. So we've got 3 primary districts that sort of house those sort of specialty crops, and that's the St. Mary's, which is the Tabor Irrigation District is a part of that now. It's the biggest irrigation district in the country. The Lethbridge Northern just north of us, and then the BRID north and east of us. So lots of irrigation, lots of specialty crops grown in those regions. So I'm going to go through a couple of maps that just show the distribution of crops grown on the prairies. So it's sort of the relative density of a variety of different crops. The red means there's a higher density of certain crops, whereas the blue would be a paucity of those crops. I'll start with canola. Canola, I often think I see a lot of canola here in southern Alberta, but relative to other areas on the prairies, we're really not big canola growers. Lots up in that Yorkton, Melfort area. Robert maybe would be familiar with that. Even when I think about driving up north to central Alberta, I feel like there's a lot of canola there. When I head up to Drumheller, Red Deer in the summer, lots of golden fields, and that's not even the high density that we see in that central Saskatchewan area. Barley is highly concentrated sort of in that Highway 2 corridor. lines up a lot with livestock production. Cereals, more broadly, still that same concentration in Alberta, but there's a lot more grown across the prairies. But as we move into some of the more specialty crops, you can see how concentrated they are here in southern Alberta. So edible beans, for example, very little grown outside of sort of this Lethbridge area, east of Lethbridge. Corn, even more concentrated in Lethbridge. That's probably to some level tied to the livestock production industry. And potatoes, that's another one that's highly concentrated. So one of the things we've noticed with some of these very specialized, highly concentrated industries, because they don't have that footprint in terms of acreage as some of the other crops, it's a little more challenging to get relevant research to support those industries. They often draw on research or draw on practices that have been gathered from other areas with maybe different climates, different contexts, different cropping systems. And it's important for us to take the time and energy to research locally and regionally how they adapt to our climate, our cropping system. So that's a little bit of what I'm going to touch on through the rest of this presentation. So among the irrigation in Alberta, those specialty crops, that's the green line with the triangles, they're about 20% of our irrigated acres across the province are specialty crops. And among those specialty crops, I'd highlight potatoes as something that's gone from 40,000 acres to 60,000 acres in the last 10 years. And it's actually gone up by 10,000 acres from 2020 to 2022. So big changes sort of to the landscape here, and something we need to sort of keep our eye on and make sure that we can, if expansion continues, and my understanding is after a pause that is likely to happen, that we need to be doing that responsibly and making sure we can integrate it with all the other crops we grow and make sure we protect our production at the same time. But irrigation is unique not because of the crops grown, but it's also just a lot of the production factors that fit into the irrigation dynamics. High residue, high production is a big factor, so we're dealing with a lot of, maybe 4 or 5 times as much plant matter left on the surface every year that we need to figure out what to deal with, whether we remove it, we have different seeding systems to manage that residue. So it's a factor that not everybody has to consider. We have high producing crops, higher value crops, more profit, and that does impact the equation when we consider things like crop protection. We've got irrigation that increases our risk for disease. So all these factors make our inputs, the consideration for how much we invest in inputs and how much we get out of yield, just a little more complicated. Water management is something that's really not a consideration, obviously, if you're not irrigating, but there's a lot of pieces to that, and I think we've done relatively well. But as we sort of move into potential for more limitations on water, knowing how much to water, when to water, and perhaps where to apply it, not only within a field, but within a farm with a variety of crops is going to be important to better understand moving forward. And the profitability of irrigation is an important consideration. We have the capacity to put big investments. We do put big investment, not only in terms of crop inputs to maximize our yields, but land values as well are a lot higher under irrigation. So there's a high risk, high reward in that irrigation environment. And again, that's an important consideration when we think about how important it is to be generating a robust data set and management practices for our irrigated crops that's relevant locally. So I'm going to move into some of the research that we've done on a few different specialty crops in the last couple of years. I'll start with some fresh pea cultivar work that we've done with Norterra, formerly Bonduelle, formerly Lucerne, over the last couple of years here. So this is a really good example of one of these very regional crops with a small footprint locally, but actually has a lot of production in other areas of the province. There's quite a bit of work certainly in Eastern Canada, Ontario, and Quebec on fresh pea harvesting. And what happens locally is because the footprint is small, there's not always the same capacity to do research locally. So we draw on information, we draw on practices, cultivars, performance that is generated elsewhere, and we try to pull it in locally. And in this case, Norterra asked us to conduct a cultivar test locally to see how these varieties performed in our environment and if it was reflective of what they had seen in other places. So if you're unfamiliar with fresh pea harvesting, it's a completely different dynamic than most of our crops that are allowed to senesce and mature and dry down before we harvest. They're harvested fresh, and as the peas mature, they slowly get firmer and larger, and there's sort of an ideal window between, for that tenderness, firmness, and size of the peas. So if the peas are too small, that's considered lost yield potential because we've harvested, they're no good for human consumption, they should have been in the field for maybe another week and grown to an optimal size. So we don't want to harvest too early. We also don't want to harvest too late because if the peas get too hard, they're again not really a premium product anymore, and they're not as valuable. So every variety sort of has a different amount of time that it's in that ideal window for that tenderness, and it also has a different time in the season when it peaks. So there's short season, mid-season, long season varieties, and it's important to identify how these varieties perform locally in that context to help with that sort of quality control and harvest management piece. So we set up a trial in a farmer's field, 24 different varieties, and we did a number of evaluations, and we gathered big bags of plant matter that we brought to their mobile testing unit, which basically threshes out the peas from the plant matter. So we separated those peas into different size buckets, and essentially we determined what the net yield was, taking off the smalls, taking off the bigs, and this is sort of what our actual yield was at this time. And then the peas are put into this aptly named machine called a tenderometer. So really what it is we take that sample of peas that are the appropriate size, appropriate tenderness, as far as we can tell. We put it in that little box. And really what it is it's an adapted hydraulic press. So it squishes the peas through the grate and measures how much pressure it takes to squish those peas through. And that's converted into a tenderness rating. So essentially, if the peas are too soft, it'll squish through too easy. And if the peas are too firm, it'll take too much energy to squish them through. So we're trying to identify, and what we did with these varieties was we harvested them, say, every other day, every 3 days, to kind of generate a bit of a timeline for when they hit that harvest window and when they moved past it. So this is what the results of that look like. That harvest window is that thick blue line on the bottom. That's sort of the sweet spot. That's where we want the varieties to be when we harvest. So looking at this, each of these lines is a different variety. So when we're sort of analyzing this data, we're trying to identify varieties that have more of a shallower line, meaning they're in that sweet spot a little bit longer. And we also want to identify short season, mid-season, and long season varieties. So Norterra will then take this information and use it to develop their seeding plan and harvest plan for the year. So all the equipment is owned by the company, and they'll kind of move through field by field as fields are ready. So the worst case scenario is to have a dozen fields already in that ideal harvest yield parameters on the same day. So using this information, they can kind of set up a sequence and order for when they plant so that harvest can kind of progress sequentially, step by step, and we're achieving maximum gains from the acres planted. And of course, if there are different varieties that perform the same on the tenderness piece, then we want to dig into the sort of yield parameters as well. So if they perform comparatively, which one yields better. And so we'll continue this over a number of years and build a larger body of data that we can use to sort of better guide that. So I think the particular varieties probably aren't of interest to a lot of people, but if you are, come chat to me after. I can share this information. So the next steps for our work with the fresh peas is first of all to continue the varietal testing. So we'll continue this experiment for the next couple of years, and we're going to begin similar testing for fresh corn. So again, this sort of specialized vegetable market, vegetable processing industry that we're supporting. Seed canola is another high-value specialty crop that's highly concentrated in this area. I showed that map earlier of where canola tends to be grown, and there's not a lot of canola in this area, which is probably why seed canola is a really good fit in addition to the irrigation aspect. I can't imagine trying to deal with isolation issues in northern Saskatchewan. So the dynamics of seed canola, it's challenging to grow for a few reasons. Seed crops in general, you sort of bring in the pollination. The pollination aspect, you're dealing with males and female plants. You're trying to separate them. And because it's canola, we're trying to create, well, we're using a planter because we have a high value seed that we're seeding at relatively low rates. So the planter's an aspect of it. And in a lot of cases, we're using sort of full tillage to plant that canola. But the risk with that tilled soil is we have, this is another environmental aspect of southern Alberta is those Chinook winds. So they can blow the seeds out of the ground. They can deposit soil on seeds that are seeded. They can even cause wind shear as the saltation and transport of particles hit those canola seedlings or pinwheel them. So wind erosion is a big risk for seed canola. And when you consider the risk of having to reseed 2 or 3 weeks after, in terms of both cost and losing 2 or 3 weeks of the season, it's really important to sort of consider having a new approach to protecting those seedlings. So strip till was one approach that there's a grower in the area that's looking into. So we worked with them to try to evaluate it in the field. So this is what that strip till looked about 7 days later. So we compared strip till to full tillage to direct seeding. Now, one of the challenges with this particular trial is moving from those 3 different, soil management approaches with a single planter. It was really tough to properly adjust it, and I think especially when we move to the full till, you've got residue managers, you have down pressure, you have a seeding depth. So there's a lot of pieces that need to be adjusted to make it comparable. So for a research standpoint, that was a real challenge, and I'll touch on it later, but I'm not sure we did as good a job on that piece as we could have. But we did, so anyways, we seeded into those 3 different, so the direct seed was direct seeding with the planter into a pretty robust fall rye cover crop. And again, you'll see later, but it worked a lot better than I would have expected. These temperatures do match a lot of what Carlo saw in sort of the small plot aspect, where we had higher temperatures on the full till. The strip till was warmer than the no-till, but below the full till. And then no-till was kind of the coolest soils. And we took temperatures at both 1-inch and 2-inch depths, and they were virtually the same across the 1-inch and 2-inch. And by the time we got to early June, there was virtually no difference in temperature anymore. So plant counts, the strip till and no-till, so the direct seeding, those were comparable to one another, but we actually had lower plant counts, lower emergence on the full till. But my suspicion here is that we had trouble properly adjusting the seeder. So you go from this direct seeding where you need a lot of extra pressure and you're transferring to sort of a light soil full till. And I wonder if we seeded a little bit too deep to be sort of a fair comparison on that. So take that result with a grain of salt. But certainly the strip till, full till, strip till, no till, not a lot of difference. Visually, I was really impressed with what that direct seeding, so on the far right, top right corner, that direct seeding came up really nicely. It looked just as good as everything else. So I don't know if we had the perfect conditions, the perfect equipment. Maybe we just had the perfect operator, but that worked really, really nicely. I was really happy with how that turned out. And throughout the season, it was really hard to visually identify differences. So the bottom 3 pictures, that's sort of when we're getting into flower. And I would say that the no-till, the direct seeding, was maybe 20% flower stage behind. So it was slightly behind, but it was nothing that you'd be able to see driving 100 kilometers an hour past the field, AKA scouting. So on the yield standpoint, pretty much the same, no difference. But because I know you're all curious, and I have to say there's no statistical difference, but there is a little bit of daylight there. So the strip till did outperform, but again, not a lot of confidence in knowing that you'd see this, that you could expect a yield advantage with the strip till. One of the more topical elements of specialty crops right now is the soil erosion piece that we deal with following potatoes and sugar beets. So these are root crops that require quite a bit of digging to remove the crop from the soil following harvest. So we did a couple of trials looking into better ways to manage soil erosion using cover crops. And I'll say, I guess before I get into it, there's quite a bit of difference year to year how different practices work. So the first year we did it was 2022, and we followed both potatoes and sugar beets after harvest. We did broadcast and direct seeding of different cover crop blends, different seeding rates, and just because of the year we had, I mean, virtually nothing came out of the ground. So we seeded probably middle to late October after the sugar beets, and not a chance that anything was going to come up. And the potatoes too, that was probably seeded early October. Nothing came out of the ground. Maybe the odd, 3 plants kind of thing. Pretty depressing to do plant counts. Unless it's cold, then you're back inside in a hurry. But this year, this is our picture from this year of our potato cover crop. So I don't have data for it right now, but we had a wide open fall. I think that crop was probably growing to the middle of November. It was just huge, the difference in performance here. So that's sort of where, it's nice to kind of do one-offs and try things here and there. But year to year, site to site, huge differences in how things turn out. And is this going to be representative of what we see long term? I highly doubt it, but it worked this year, and if it works however many years out of how many years, maybe that's enough. So digging into it, we did one trial on potato nurse crops. So for potatoes, it's quite common to do some row marking or pre-hilling the fall before, just to kind of loosen up that soil, have it exposed to some freeze-thaw cycles. But it does expose that soil to erosion throughout the winter. So we decided to broadcast a number of different cover crops ahead of that tillage operation. And then when that pre-hilling operation went through, it would turn all these crops into the soil, and they'd be there and hopefully grow enough to get established. So we would have done this about the probably second week of September, 7th to 10th of September kind of thing. So here's our different treatments, and this is what it looked like sort of end of September. We had quite a bit of growth. Fall rye, winter wheat, winter lentils, Italian ryegrass, all of those actually did grow quite well, so really happy with that. Keep in mind the bare soil on the top left, there is growth there, so regardless of what cover crops you do or don't seed, there's still weeds and volunteers that are going to come up, so we sort of have to compare our performance against that as a check. Winter camelina was a crop that I really thought was going to be more beneficial than it was. It's the kind of crop that it can actually continue growing until about -12, -14, so it takes a really deep freeze to actually stunt its growth, so it'll grow late into the fall. But the challenge here was because it's a shallow seeded crop, and we're sort of tilling it. We did that broadcast tilling application. So I'd say, probably 80 to 90% of the seeds were an inch or 2 or 3 deep in the soil. So it wasn't really, the application method wasn't really conducive to success there. The following spring, this is what things kind of look like. The fall rye grew super, super well. In fact, it grew too well. It was almost difficult to get through when we were seeding the potatoes. So for that reason, I'd say that's not a great option unless we sort of play with the seeding rates. Winter wheat gave us some really good crop cover. And the winter camelina was, in this picture, it shows pretty decent cover, and I chose that for a reason, but it was quite variable. And I think that's due to the, some of them emerged, some of them didn't. But I think there is potential there. It's maybe that seeding method isn't an ideal fit there. So we had intended to repeat that experiment again this past year, but because of water limitations and low soil moisture, it just wasn't a fit for trying to get anything established and risking tilling that soil without a cover crop. So hopefully we can kind of try it again this coming fall. But again, these are some of the dynamics with the year-to-year variability. There's not always a single strategy, especially when we're talking late in the season. We've got a rapidly vanishing, window of time to actually get something established. So if 1 or 2 things go wrong, there's very little opportunity to get something to protect the soil. So then we're back to sort of a zero risk, zero till scenario for the winter. I mentioned our sugar beet cover crops didn't work at all. Sugar beets are harvested quite late, so there's usually a bit of an early harvest, but when you kind of do that late, once you're getting into October, conventional wisdom is like by middle of September, you should have your cover crops seeded. Maybe you can push it with different crops, but when you're talking sugar beets and you're getting into middle of October, not a chance you're gonna reliably have some cover crop unless it's this past year maybe. So we went back to the drawing board and thought, what if we gave those seeds a little more opportunity to grow? So we tried to do some inter-row seedings. We seeded our cover crop blends middle of June, so after the last herbicide application, before row closure, and it actually worked quite well. One of my big concerns was, how much damage we might cause to the crops, and it actually was pretty minimal. So in our case, so the crops are just starting to crown. That's a big no-no. You don't want to hit that, but you can hit the leaves. And our tires, so we've got 18-inch tires. We don't have narrow road tires yet. We'll have them for next year. But even with our tires, there's plenty of clearance. When we came back, say, a week or two later, you couldn't tell which rows had been driven through or not. Obviously, as a farmer, if you're going to try this technique, you'll have row tires. And I sure hope you have more than 4 rows on your planter, so the impact of the tires is not going to be as significant. So 3 cereals we tried: winter wheat, fall rye, and barley. Everything actually came up really good to get started. So, there's a bit of a time crunch, right? You've got maybe a 1 week, 2 week window before you get canopy closure. And once you get that shading effect, it's really difficult to get any growth. So happy to see some early season production out of these cereal crops. Now this is in October, late in the season. These pictures are sort of like the best case scenario. So this is where things were growing really well. Results were super variable throughout the trial, but happy to see that there's some real potential for winter wheat, fall rye. Barley, maybe not as much, but there was some growth there. So following harvest, so the way the harvest mechanism works, for those not familiar, is first the beets are topped, so all that foliage, plant matter is strewn about over top, and then the diggers come and dig out the beets and dump the soil sort of on those rows in between. So our cover crops do get covered with the soil for the most part. Winter wheat and fall rye actually looked pretty good. Fall rye especially, like there you could see the green all the way down the rows, so I was pretty impressed with that. So that's not only like plant matter and root matter, but it's living root matter for both of those crops. So it's still there, it's still active. Anything that's poking out, still getting sunlight, still getting some growth and capacity to hold that soil together. Barley, on the other hand, a little bit more sporadic down the rows, kind of appeared in clusters. It's not living root matter, so I think its capacity to hold the soil will be less, but again, some success there. Certainly better than some of the other options we tried. We threw corn in there, kind of knowing it wasn't going to be a success, and we were right, it was terrible. Ultimately, the corn just outcompeted the sugar beets way too much. We thought, it's a glyphosate-tolerant crop. We could maybe seed it earlier, get some growth, but ultimately, it's tough to see in this picture, but you could see in the sugar beet leaves, they were lighter, they were competing for nutrients, so really not a viable option, but sometimes you have to try those non-viable options just to know how good everything else is. The corn gets chopped off during the topping of the beets, so there's just a few little spindly stalks down the row, nothing that I'm expecting to prevent a whole lot of erosion. So I'll mention that we've kind of been monitoring these trials throughout the winter, so we're going to sort of have a more complete picture come spring. Winter lentils came up pretty good under the canopy. And actually, I don't know how well you can see it, but in places they grew really, really well, and didn't have that same noticeable impact on the sugar beet production as the corn did. And then because they're sort of they don't have that really stiff, stocky stem like the cereals do, so when all the debris gets piled on top of them, they get buried and flattened. And when I came by after harvest, I didn't think there was any lentils left. I thought, where did they go? But pretty much everywhere where I would dig in, I could find some of those lentils kind of hidden under the soil. So there's, green plant matter, living root matter for some amount of time. So we'll follow up on that. But that seemed like maybe one of the better performing options relative to the fall rye and winter wheat. Sudan grass, we thought we'd give it a try. So the sorghum Sudan grass is sort of a late season, hot season crop. We thought it would really grow well, being planted in June later in the season. And it got started okay, but it got, once it got shrouded by that shadowing effect, it really got choked out. So didn't work great. This picture shows probably the best spot where it grew, and it looks decent. It gets cut off, but there's a whole row of those Sudan grass stems. So we'll have to see. We'll try it again next year, but a lot of areas, there wasn't much left to be seen sort of at harvest timing. So one of the things we're thinking about maybe testing next year is, can we seed a little bit sooner? Can we add another 7 to 10 days? Maybe we sacrifice that third herbicide application and seed a little bit earlier, and maybe we get a little more growth out of these plants and a little more left at harvest, provided because that shading effect, right? We've got 10 days to canopy closure. That's not a lot of time to really get things established. Winter peas was probably a failure, I don't know, on par with the corn, but it didn't work at all. It got shrouded out and didn't grow. And this is sort of in October, when that biomass sort of starts shrinking up again and a little more light comes through, and that's where some of the plants started emerging fresh again. So yeah, pretty fun trial to do. It was something interesting. We had some support for a project like this that gave us a lot of flexibility, which is really nice. We don't often have that. So we have the capacity and have had the capacity to try something, see what works, see what doesn't, pivot and adjust and try it again. So for this next year, I'm interested in trying to seed a little bit sooner and see how that works with competing with the sugar beets. We do have yield data, by the way, but we haven't kind of worked through it yet, and sugar content. So anyways, to be determined on this, but anybody who's growing sugar beets, I'd be interested in hearing your feedback on other things we might want to include in our version for 2024. So finally, I'm going to touch on some manure and silage corn. Obviously, this is a pretty locally relevant project. So George Lubberts, so we had a conversation probably about this time last year, and he said, I've got all these clients, and I'm noticing that their corn crops and their canola crops following manure just really don't look like they're coming out of the ground as well as we'd like to see. And he wanted to confirm whether or not that was that bias, was what he was seeing real, or was it not? And secondly, was it consequential? Did it make a difference for yield? So we partnered with a few local farmers and set up a manure trial. So alternating strips of, say, 40 tons an acre versus bare soil, and then planted corn following that. One of the more risky videos I've taken, no dents in the truck that day. But yeah, this kind of trial, it's a lot of coordination, and we'll kind of see that on the harvest timing as well. It's tricky to get, you've got a dozen people applying manure, you're trying to make sure everything's happening at the right space, at the right time, and making sure you have something that you can use for a trial. But everything actually, for the most part, worked out really well. So heavy manure on the left, no manure on the right. So this is kind of getting into that emergence timing, and I'll give you a couple seconds to make your own assessments. But to my eye, the absence of manure, those crops look more uniform, they look greener, but it's tough to say, and it looks like there's more of them, but it is tough to say how much of that is sort of like a trick of your eye, or does the manure make the soil look a little dirtier and it's hard to identify the green? And I guess that's where the data side comes in. And we did plant counts, we did pretty thorough plant counts 4 different times throughout the spring, and ultimately, there was some variability, but no difference. So statistically, no difference. So the number of plants was exactly the same. Exactly, it was pretty much the same, manure versus no manure. But when it came to the growth of those plants, in the absence of manure, the plants grew quite a bit better. And by the 1st of July, we were about a half leaf stage ahead. So that's the V stage for corn. So at that stage, that's a pretty big difference. And we measured, I'll get into the height differences later. And I should mention that we did take care to ensure that fertility was comparable across, so it wasn't any fertility limitations. So this picture illustrates that actually quite well. The one on the right, that's our no manure. You've got these straight rows. You can see the plants. They're all the same size. They all look tall and healthy. On the left, there's probably about 30 or 40 plants there that look like they're half the size of the rest of them. And that's something we saw it was obvious as we were moving through the fields that there were plants that just were struggling to grow as well as other ones in that manure environment. And we've had conversations since, and we don't know why that is. Is it cooler soil because the manure is there? Is it a salinity effect? Is it just the disturbance of the soil? Everything was tilled after manure application and before seeding. But yeah, so the question's out there. Why are we seeing this difference? Our heights, the numbers are maybe a little small to see, but we're looking at about a 7-inch difference on 1st of July. So 7 inches, and that's not even getting into the peak season of corn. So that's a pretty big difference. So I talked about some of the challenges with this trial, and harvest was probably one of the trickiest aspects of collecting data for a field trial we've had. Not only do you have maybe a dozen people out there running different pieces of equipment, but collecting an accurate yield sample requires me to be organized, requires two different operators to be on the same page, driving the same speed, and it also requires not to get stuck in a mud hole. And we did have a few challenges. So we had a few places where we had to throw out a couple of samples, but we did end up with enough across our two locations to be reasonably confident in our yield, and no difference statistically. So there were some numerical differences, but pretty highly variable data set. So it'll be interesting to dive into it again, but no yield differences. But I surmise that because of the year we had, again, we had this long open fall. So this was chopped before we had any killing frost. So that corn, any corn that was behind, had plenty of opportunity to continue growing until harvest. So I wonder if we run into a year. Mike had a picture with big snow on September 30th. If we get a killing frost September 15th, maybe we have a different outcome. So be interested to sort of explore this in different years, different environments. So next steps for this trial, we're looking to do it again this year, and we'd also be interested in looking at canola. That's the other crop that George had been quite curious about. So anybody out there who's kind of got the same questions, give me a shout. I'd love to kind of include you in this study, so we might be looking for folks to work with us on that. So what's next for irrigated specialty crops? All these projects that I've touched on, and there's some more. We've done quite a bit of work with seed alfalfa as well. That's a very, again, southern central Alberta focused production system. But we're continuing research with all these ones I've touched on. But I've got, I guess, two major avenues that I would suggest that I would suggest there's opportunity for continued research. So one would be just on irrigation itself. I've touched on it a little bit. We've had extreme moisture limitations the last couple of years, last year in particular. We've also had limitations on irrigation water. So how do we responsibly manage this resource? And how does that fit in with the dynamic of, perhaps an appetite to expand irrigation acres? So I think decision support systems, I think making sure growers have the knowledge, have the information, real-time information about what's happening in the soil so you can make informed decisions about when to water, how much to water, and I think also where to water. I think, if we consider the possibility of say, a 20%, 40% reduction in irrigation water available, how do we manage that on a farm scale, not just a field scale? What do we divert to where? How do we allot water in a way that allows us to produce the highest yielding, most profitable farms, not just fields, but farms? And I think there's a lot of information out there, and we have to bring it all together into one place. And some of it may need to be updated to current genetics, current practices, the way we're farming here in 2024. So I think there's a lot of space for water management on its own. And the other big one where I see opportunity is the potato industry. So this picture is of a potato planter, a 2-row planter that will be in our shop in about 6 weeks, fingers crossed. It's a 2-row planter, cut planter that gives us the ability to control the seeding rate and the row spacing width, fertilizer, granular, and liquid inputs as well. And this is the example of an industry that draws a lot of information from other places. A lot of our potato research comes from Eastern Canada, comes from Idaho, Washington, but to my knowledge, not a lot of it has really been adapted in a research context or tested and verified in a research context right here in southern Alberta. So we're interested to step into that place and help support the potato growers who, to be honest, I think have done a really good job of taking information from other places, and the success of the industry speaks to that capacity to adapt technologies to the local context. So yeah. So I think we'd like to kind of be in there, be in the mix, and help take the edge off. So you don't have to try this on your farm, on a production acres of potato. We'll try it in small plot. We'll figure out what works and what doesn't, and we'll sort of fine tune that. So again, Mike talked about that, crossing the chasm. So we can sort of kind of stem the loss on that bleeding edge for those real innovative growers there. And I think there's plenty of opportunity as far as nutrient management, seeding systems, tillage, And a high-value crop like potatoes, I think because of the high value, because of the cost it takes to grow it and the profit there, it's sort of like a magnet for all sorts of products and chemicals that, some may work better than others. And we'd like to help identify, what are the winners, what's going to be the best bang for your buck. So potato research, I think, is in the future. So with that, I hope I've made a good case for concentrating research energy and dollars on specialty crop research here in Southern Alberta, because we do have a very specialized, very unique environment, unique crops, unique systems. And in my opinion, we need to be doing research that's relevant to our crops and our production systems. And that's going to help us to continue to be profitable and world class. So if anybody out there has any ideas, challenges, questions about specialty crops or irrigated productions, I'd love to have a conversation with you.
Thanks, Lewis. Any questions?
Besides the rainfall, how much do the different soil classifications make a difference in your trials?
In my trials, so it makes a big difference. Actually, it's almost jarring how much difference there is regionally in soil type and environment. So if I do a trial, even from Lethbridge to Tabor, we may have different outcomes just from the soil types or from field to field, location in the field. So it does have a big effect, and that effect changes depending on conditions. So we've had, if we have a really hot, dry spring, certain soil types might be better for certain crops, or if we have a, cool, wet soil, well, you might have better drainage here than there. So, it's one of those things where doing research, I found that every year, every location can be really different, and that's why building a broad body of work is important, because then you can identify those ones that are kind of outliers and what's more applicable. But it's also why I would advocate for regional research, so to do work in Alberta that's relevant to Alberta. So I hope that answers your question. Yeah.
Lewis, Ken Greer from Western Ag in Saskatoon. Question about the manure.
Yeah.
So not all manure is made equal, even though it comes out of animals. Can you describe a little bit a liquid manure? Is it bedding? Is it composted manure?
Yeah.
Help us understand a little bit, because I'm struggling to try and find a mechanism that would restrict the corn at that much.
Yeah. So two different locations, two different manure sources. So one had been, so it's cattle manure, so right out of the pen. It's not liquid. It's got straw and other debris mixed in with it. So one location was stored over the winter to compost, so to speak, but not sort of managed in a compost way, right? So you kind of have some of that decomposition aspect. And the other was straight out of the corrals in the springtime. So heavy, but it does add a lot of residue, right? The cattle manure, there's a lot of straw in it, but it's not that heavy ammonia, liquid manure that you might be dealing with on the dairy side.
Just to follow up then, and we can talk about this later, but there is potential for initial immobilization phase where nitrogen is being not mineralized but taken up by that heavy bedding. And
yes.
And corn is very sensitive to early nitrogen supply for success. So,
yeah.
But we can talk about that.
Yeah.
And I'm sure that George will jump in, because it's a great project. And useful for anybody who's looking at spreading manure. Just for clarification, because most people have manure and the close to their heart as really valuable.
Yeah.
Thanks.
We did ensure that there was enough available nitrogen kind of to start as a baseline, but I don't know if George.
Yeah, the soil tests we took beforehand, before the manure application, one field we actually had to add a bit of nitrogen to make sure we had sufficient there. The other one was, well, because they manure it almost every other year, the nitrogen levels are very, very high. So I don't think that might have been an issue, but seeing it show up in both, and over the years, just the visual observations I've been making, the reason I asked Lewis to look into this was, I mean, yeah, and it seems to be the years where there's issues with, like, whether it's hotter and drier and water uptake. So I don't know what, yeah, again, I don't know the reason behind it, but we are going to try again, and we're hoping, you know, if anybody here wants to get involved, be great. But we also would love to do it on a canola field. The plan was to do one canola field, one cornfield, but because of crop changes, we ended up with 2 cornfields. Any other questions?
Just another idea on the manure. You know, sometimes there's other compounds that could be toxic to the corn, even just slightly, and it just sort of slows it down a little bit. You know, it's really hard to research that, because when you have to find if there's anything there and then identify what product or what compound it is. But you know, there's a lot more in residues than we realize, and when the microbes start breaking things down, there's secondary metabolites that are released. Sometimes they're good. Maybe for some crops they're not so good.
Yeah.
It's hard to say.
Yeah, and our approach with this was, number one, to determine whether George's observation was legitimate. You know, was it something that's real? And I think now that we've seen it, I think step 2 is to, yeah, dig into some of those things. So why might it be? And yeah.
And Tom, we'd be happy to take funding to do more of that research. With that, we're going to take a break.